Good morning everyone. In this session, we shall understand triple DES. Or it is also known as 3DES, or we also call it TDEA. So, before going into the details of triple DES, we know that what is DES. If you don't know, we can go through the books, or I have released my video of DES in two parts. Anybody can go through that video and can understand DES. So, after understanding DES, it would be better to understand triple DES. But even if anybody is not knowing about the DES, what is DES, still partially the person can understand what is triple DES or 3DEA. So, what we have seen, DES, when first time published, it used 56 bits. Initially it was 64, but it is reduced to 56 bits plain text as well as 56 bits key size. So, that one was sufficient enough to encrypt any plain text, and it was quite impossible at that time that anybody could decode it, anybody could intercept the plain text or ciphertext. But as the time passed, the computational power of computer increased. So, with the increased computational power, it became easier for the adversaries or unauthorized third party to grab the text and to intercept the ciphertext. So, security of the message of the sender went into threat. So, change and advancement into this DES was made, and it was known as TDES or triple DES or 3DES or TDA. So, what is this triple DES? So, as the name indicates, very simply speaking, DES is applied 3 times. 3 DES meaning thereby application of DES 3 times. So, now we understand in detail what is TDES, triple DES. As we know, this is the plain text of 64 bits. Now, here we perform encryption into DES algorithm. So, here we use a key K, and after processing we get a cipher code, ciphertext, which is a coded text. So, this happens in DES. This is the entire process of DES. The plain text enters into DES algorithm by the application of using a key K, and after coming out of it, the plain text is converted into ciphertext. So, this is the DES. Now, what we have to do here, we have to use one key K1, then this we do not write as a ciphertext, this is a coded text, intermediate text. After this, a text is obtained as like in DES, but this time we do not call it as a cipher text, it is an intermediate text or middle text or a coded text that is different from the plain text. Now, here again on this coded text we apply a decryption process on this coded text, decryption DES, and here we use another key K2. Am I clear? After this encryption we get a coded text. Now, on this coded text we perform decryption process and we use another key K2. We do not use this K1. So, if we use K1 here, then this would be converted into the plain text. Okay? So, we do not use K1, the process is of decryption, but the key has been changed. Another key we use. So, after this we get another text on which we encrypt that text, and here we can use either K3 or K1, right. Here we can use another key K3 or this key, the key that has been used first time for encryption, K1. So, we will understand what happens if we use K3 and if we use K1. So, here we take K1 and after this we receive the cipher text, and now this cipher text is sent into the transmission through the secured channel. So, this is the entire process of triple DES. I am again repeating it. The plain text of 64 bits enters into this encryption process using 56 bits key K1, and on this coded text we apply decryption. For this we use another 56 bit of key K2, and the resultant text is again encrypted with the help of either K1 or this key K1 or K3. So, here again we get 64 bit of cipher text. This, if it is K3, then it is again of 56 bits. Okay. So, what happens with the decryption? Decryption at the receiver end, how we can decrypt the cipher text into the plain text at the receiver's end. So, we reverse the process, we reverse the entire process. So, first here it is 64 bit cipher text, and here we do just reverse process. So, decryption DES using K1, using the same key K1. Again here we get another text. As because here was decryption, we would apply here encryption. Encryption DES by using this same key K2. Right? After this, the coded text is again decrypted using the similar key. Had it been K3, then we would have been used here K3. So, we have used K1, that is why here we are using K1. Now, here we get 64-bit plain text. So, this is the entire process of triple DES. This is the entire process of triple DES. Of course, it has been given by NIST, National Institute of Standards and Technology, NIST. Okay. So, in this way, we get ciphertext from plain text. Now, we have to see what happens if we use all these keys, all these similar keys, then what would happen? This would be as good as DES algorithm. The only difference would be 16 rounds here, 16 rounds here and 16 rounds here. In total 48 rounds there would have been. So, this is as good as DES, data encryption standards. The only difference is that the number of rounds of the DES algorithm that increases. So, now if we do this, then what would happen? This is K1, this is K2 and this is K1. So, we can also understand it if it is K3 and K1 is equal to K3, right. So, in that case, what would be the total bit length of the key? It would be 56 plus 56 bits. The key space increases to 112 bits. So, had it been K1, 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 then the total bit space would have been 56 bits only. Now, if we use K2 different key, then in that case